Hi, this is Isaac from Portland. I'm the one who took the Mount St. Helens and Mount Rainier photo from Council Crest Park that is currently being used to show that the Earth cannot be flat. Um, Baldy cats slash conspiracy cats effectively ended the flat Earth debate as we know it. And then in the past few days, I've seen some people like the Rumpus and another guy who's a PhD named Philip making a beautiful, excellent presentation using the maths and yes, maths. You guys have got me saying that. And atmospheric refraction using a ray tracing program, which is just awesome. Sly did a great job visualizing all the data, both on a flat plane and a curved plane in his 3D computer representation. And I guess a guy named Sean Hufford is actually making a physical scale model that is yet to come, but will be interesting to see. Um, but we know what they're gonna say, and they've already said they've made their feeble attempts on the numbers, the altitude, atmospheric refraction, which have all been completely annihilated, dismantled by the previous guys I just mentioned. But they're going to fall back on perspective, knowing that their audience can't visually reconcile the actual effect in their heads. But I'm going to make it very easy for them today. My first picture was meant to be a sort of elevator pitch of curvature and globe. Very simple and easy and quick to understand. At least it was for me. Looking at the picture, something really big, far away, something half the size, closer. You can just look at it, and people do. They go up to that park every day, and you can just see and understand the uh, the reason why it looks smaller because the Earth is curving, and because of the distances. But this is going to be my elevator pitch on perspective. And I'm going to show you that all these guys, Riley, Ranty, Nathan, Caps Lock Bill, and especially Phuket Word, if that's how we is meaning to have it stated. Phuket? I don't know. Kind of sounds like the F word, but um, and I'm going to show you their one-dimensional thinking and expose their misunderstanding of perspective and quite honestly their lack of integrity. And it's going to be very easy and very simple using a visual model using the Walter Bislins curve calculator. So let me get started. Okay, here is the Walter Bislins Advanced Earth Curvature calculator. On the left, and so I have it set up to show both globe and flat Earth at the exact same time. So on the left we have the flat Earth, on the right we have the globe Earth. Now, my original picture was taken at a viewer height of 1,075 feet, and Mount St. Helens was 54 miles away with a peak of 8,360, and not a side peak, by the way. This is the main peak, whatever you want to call it. We're going to also add in standard refraction, which actually changes it just a tad, as you can see, but we haven't included. The second target, which was Mount Rainier, or as some people say, Rainier. But what I did is I put it at 54 miles, okay? So imagine they're right next to each other. And I could use mountains, but let's just say these are lighters, okay? Say this is a big, long table with some really tall lighters. It's easier to see, especially on this split screen view, okay? Now we have the flat Earth representation and the globe Earth representation. Now you can see they're both basically identical besides one, the globe has the curvature, so it's lower, and the flat Earth has a flat plane, and they're just identical. So right next to each other. There would be no reason there would be any difference. But here's the key. Now let's slowly move Mount Rainier in the distance back to its original location. So follow me. I'll kind of go slow and then I'll do it quicker next time, and you'll get a really easy understanding of what's happening. So we're at 54 miles, so let's push it back. 60 miles, 67, 60, 70, 80, 85, 90, 98. Oops, and then 104, which is its actual. And I'll show you the picture, the original picture, and this is what we see right here. We see Mount St. Helens, significantly taller, not the side peak, the main peak, significantly taller than Mount Rainier in the background. On the flat Earth, St. Helens is just a fraction of a tiny bit taller than Mount Rainier. Okay, so this is what we see in reality. But now we're just gonna let things go, and we're gonna keep pushing it back. And you can't do this in real life, so that's why it's hard to visualize. So all these people like Nathan and Ranty and Riley and Caps Lock Bob, Fugit Word, who say, of course it gets smaller. It's further in the distance. Well, we're going to show that on a flat Earth, that's what happens. On a globe Earth, not only do you get perspective, but you get the curvature of the Earth. So here we go. So let's just keep pushing Mount Rainier back, and what do you know? Gone completely. But on the flat Earth, it's still there. And it could just keep going and going and going. I don't know how far you could see it in real life, but that's 621 miles away. So now let's bring it back the other way. And now we see the perspective shifting. But what you notice on the globe first is the curvature and perspective at the same time. You have to just see them both at the same time to really understand that they're doing the exact same thing perspective wise. One's just getting lower. So there we are. Now we're really close, and you can see they're both very large. You can it's almost identical again. So here we go. Let's push it back. And now we're at St. Helens again, and then there it goes. Bam. That nice sound effect. Once you see it like this, it just is over, guys. Yes, the globe has perspective, but it's also going over the curve. So you can't say there's no perspective. I'm showing you. And what happens? In the real world, this is what it looks like, because in the real world, it's going over a curve and getting smaller at the same time. This has atmospheric refraction. I don't know, you could put any observer height, anything you want, and test it in this model here, or in this curvature calculator. But go ahead, give it a shot. Put in my exact my figures from where I took the picture and the distances, which are all verifiable, and test it yourself. This is what they're trying to tell you. They're trying to tell you it's getting smaller because of perspective, but they're one-dimensional. They don't think two-dimensionally, three-dimensionally. Perspective and curve. They expect the flat Earth model to happen on the globe Earth model, but it doesn't. And they're deceiving you. They're misrepresenting. I have to assume that these guys know what they're talking about. they're just trying to sell T-shirts. You know, why give up an income revenue stream or whatever for popularity, fame? You know, why give it up for the truth? Well, around here we'd call that integrity, but you know what? I understand. They're not going to change. It's the people listening to them say this every time. You need to think, are you going to have integrity with yourself? We know they don't. But you're just an anonymous person on the internet. You live with that day to day because it's very simple. But one last note, that my picture, I used a zoom and it was at 200 millimeters. So to get this kind of same um, zoom or whatever, same framing of the picture, use 200 millimeters because that's what I used. It was an older DSLR Nikon D40X on a tripod, a 200 millimeter, I think it was 55 to 200 millimeter lens, and I had it zoomed out all the way. So, anyways, that's it. Like Baldy Cat said, game over.